recording. So he did 30 squared plus 24 squared to find the hypotenuse, correct? Because he has these two measurements, which are legs, so he's going to find that hypotenuse. All right, 30 squared is 900 plus what's 24 squared?
576.
Equals c squared. Adding those together is 1476 is c squared. So c is 38 something. Yes? 42. So could the baseball bat fit diagonally along the bottom?
No.
Because the baseball bat is 40 inches long. However, that's not my only option, right? I could kind of prop it up
And make it go diagonal.
inside. I can make it diagonal across the whole thing. So, Bradley, continue. All right, so this was 38.42. So that's right here. Where'd the 16? Where's that going to go? So this is 16. This is 38.42 because there's a triangle diagonally through it, right? So that hypotenuse that you found becomes a leg. All right, so what's 38.42 squared? 1,476 point what?
Anybody else?
14? Point 1? Plus, what's 16 squared? $256 equals c squared.
Okay, so everybody should have calculators out. You should be doing this collectively. Now what do we do?
Not square it.
Add them together.
Add them together and then
She was one step ahead of us.
Square
She
root.
did it silently, but yes, add them together first and then square root to get your c by itself.
And the square root of 1,732 and 1/10 is? Which is? Right here, right? That's that diagonal. So will the baseball bat fit in the box?
Yes. I mean, technically, but since it's thicker, then it's probably the other two sides.
Right, you have to test it.
Probably have to add a lot of paper. That
yeah.
paper padding, otherwise it's just going to shake around.
How much room is left over? Well, we have 41.62 minus 40. Atticus.
I got the same answer but did it a different way.
You get the same answer. See if you get the same answer the next one. There is an additional formula. Ready? So let's write down our steps so that when you're doing your homework and you all of a sudden forget math.
You forget how to do.
So this is on page 7. Now it's cold. I'm about to.
I know. I need to close that window.
It was awful in here 50 minutes ago.
3D Pythagorean Theorem. What did we have to find first?
The bottom.
The bottom one, also called a base.
The base. We have to find the base, the length of the base. Now that could just be straight up length of the base, or it could be the hypotenuse of the base. The length of the base, or sometimes it's just the hypotenuse of the base. After you found, over here, after you found the length of the base, the hypotenuse of the base, what did you do? You use that, right? You use the base from step 1 You use the base from step 1 to find the diagonal. And the diagonal is called the what? The what? The hypotenuse. Right? Of the diagonal hypotenuse. I'm going to give you 2 shapes to do this with. You're going to have to draw some 3D shapes. Let me get my measurements right. Can you find the diagonals? All right, so the first thing we had to do in that problem was to find the base, correct? Find the length of the base. Find the length of the base. Now, what that could mean, it could mean find the hypotenuse of the base. Or it could just mean find the length of the base. There are some pictures that the length of the base, like the bottom of that diagonal triangle, isn't a hypotenuse. But there are some problems where the bottom of that diagonal triangle is a hypotenuse. So you have to do some calculations to figure that out. Or it may just be given to you. It depends. You're going to have to find the length of the base, because there's going to be a triangle somewhere. Because this is Pythagorean theorem, correct? Mm-hmm. If you're working without a triangle, stop yourself. And then you use the base found in step 1 to find the diagonal hypotenuse. So again, you find the length of the base. Now, some problems, that base length, right, you're going to have that diagonal triangle. Some of those, that base length is going to be the hypotenuse of a different triangle. But sometimes the length of the base is just there. And after you find that length of that base, you use the base to find the length of the diagonal. So we're going to practice with two different types of problems. You're going to have to draw some 3D shapes. So this is going to be 4. This is going to be 10. This is 3. And then we're going to have this shape. Right, so again, find the base. And again, you guys, I know that this does not look like a right triangle. But because it's the base of a cube, or because it's the base of a rectangular prism, it's made of a rectangle. So it is a right angle. So the base, step 1, the base, the length of the base. In this example, we have to find it. It's a hypotenuse, correct? So I find the hypotenuse, which is 10.44. Then I use that base, 10.44, found from step 1, to find the diagonal of the hypotenuse, because I can do 10.44 leg 1 squared plus leg 2, which is 4, and then find the hypotenuse. Down here in this cylinder, what do we do? Find the base. Step 1, find the base. Ariano, find the base. What is it?
So, since half of the bottom is 8.
The radius is 8, okay?
So the other half would be 8, so the base would be 16.
Because here's my triangle, right?
Yeah.
So do I have to do the Pythagorean Theorem for step number 1 in this problem? No, step number 1 in this problem, the base is 16. Because if half of it, the radius is 8, the diameter, the whole thing is 16. All right, continue.
So, and then the side you know is 9. So
Okay.
it would be 16 squared plus 19 squared equals c squared.
This side's 19 because the height is 19. So I'm just going to do 16 squared plus 19 squared equals c squared. Which is what? 256 plus 361 equals c squared. 617 equals c squared. So what's the hypotenuse of this cylinder? Oshik? Oh.
24.
Yep. 24 point what?
84.
84.